The next topic is evaluation of a postfix expression. Any algebraic expression written in the form of infix notation you feed into the computer to get it evaluated. The computer will first convert the infix expression into the equivalent postfix notation or prefix notation, and then only it would evaluate the postfix or prefix notation. So any normal expression you feed into the computer to evaluate it, the compiler would either convert it into the postfix notation or prefix notation, and then only it would start evaluating the actual expression. Here, for performing both the task, which means converting the infix expression to the postfix expression and also evaluating the postfix expression, would make extensive use of the stack as a primary tool. Using the stack, any postfix expression can be evaluated very easily. So here these are the steps to perform evaluating postfix expression. The very first step is every character of the postfix expression is scanned from left to right, and the second step is if the character encountered is an operand, it has to be pushed onto the stack. If the character encountered is an operator, then the top two values are popped from the stack, and the operators are applied among those two values, and then again the result must be pushed onto the stack. Recursively we are supposed to perform the stack until we complete scanning all the symbols from the input expression. Let's take one example and solve it. This is the given example. The given postfix expression has been given. Now we are supposed to evaluate this postfix expression and find out the final answer. So any infix expression must be converted into the postfix expression first, and then only we can evaluate the postfix expression and find out the final answer. This is the given example. Let's solve it now. So here, when it comes to the conversion of infix to postfix expression, we used operator stack, but here we are going to use operand stack. Here we are going to use operand stack, which means whenever we encounter the operand, we are supposed to push it onto the stack. Let's solve it one by one. The very first step is scan every character right from the left to the right. The very first symbol is, the very first character is 5, which is an operand. Since it is an operand, push onto the stack. Next symbol is again operand. Since it is an operand, the correct character is operand, push onto the stack again. Now into the stack 5 and 3 would be there. The next character is an operator. If it is an operator, you are supposed to pop out, check here, check the third step. If operator is encountered, then the top two values are popped from the stack. Top two values are, the top element is 3, pop out 3 first, and then after popping out 3, only 5 would be there. 5 would act as the top element, pop out 5 also. Top two values are popped out from the stack, and operator is applied. The current operator is applied on these values. Current operator is plus must be applied on these values. 5 plus 3 would be 8. Then again, after applying the operator on the values, finally the result is pushed on to the stack. The result is, after applying the operator on these values, the result is 8, and the result must be pushed on to the stack. And the next symbol is 6, which is an operand. Since it is an operand, you are supposed to push onto the stack. Already 8 was there, now you are going to push 6 also onto the stack. The next character is an operand. Again you push onto the stack. 8, 6 was already there in the stack. Now you are going to add 2 also into the stack. The next symbol is division operator. Since it is an operator, you are supposed to pop out 2 elements from the stack. 2 I am popping out first because the top element is 2. After popping out 2, there would be only 8 and 6 in the stack. Now again 6 is acting as a stack top element. You just pop it out. Pop out 2 top elements and apply the current operator on these values. Yes, current operator is applied. 6 divided by 2. The result is 3. Push result onto the stack. After popping out these two, only 8 would be there in the stack. Now after applying the operator between these two values, we are getting 3 as a result. Push 3 onto the stack. Next, the current operator is star operator. Since it is an operator, again pop out top two values. Top two values are, first top element is 3, next top element is 8. Pop out 8 and 3. Now the stack would be empty and the current operator is star. Apply on these two values. Now the result is 24. Once you got the result, you are supposed to push on to the stack. I pushed back the result onto the stack now. And the next current symbol is 3, which is an operand. If it is an operand, you are supposed to push into the stack. Already there is 24 into the stack. Now I am going to push 3 also onto the stack. And the next operator is, the next character is an operand. Since it is an operand, push onto the stack. Already 24 were there and 3 were on top of 24. Now we are going to push 5 on top of 3. The next operator is star. Since it is an next symbol is star. Since it is an operator, you are supposed to pop out top two elements. 5, you just pop out 5 first and 3 next. Apply the current operator star between these two values. Now you will get the result 15. Now after popping out these two, inside the stack there would be only 24. After applying the current operator on top two values, you got the result 15. You push 15 also onto the stack now. The next symbol is plus operator. Since it is an operator, again we are supposed to pop out the top two elements from the stack. Pop out 15 first and then you pop out 24. Now the stack would be empty and the current operator is plus. Apply this plus operator between these two values and you would get the result 39 now. After getting the result, you are supposed to push on to the stack again. 39. Now in the stack only 39 would be there. Check for the next symbol. There are no more symbols to read here and this is going to be the final answer. So any expression would be given in the form of only infix notation that must be converted into either postfix or prefix. Here we converted into postfix first. After converting it into postfix, you can perform evaluation. At the end of the evaluation, you will get the final answer for the given infix expression, and this is the answer after performing the evaluation using a stack data structure. Let's discuss one more example. Example number 2, and infix expression of this would have been solved already under the video of infix to postfix conversion. Let's evaluate it and see what answer we are getting. The first character is an operand. If it is an operand, we are supposed to push on to the stack. Current symbol is an operand, push on to the stack. The next symbol is 3, which is an operand, push on to the stack again. Already there were 3 in the stack, now I am going to push 3 on top of 9. Next symbol is again operand. Since it is an operand, push on to the stack. The next symbol is star operator. Since it is an operator, you are supposed to push top two elements. The top element is 4, the next top element is 3 and the current operator is star. Apply operator on these two values and you would get the result to 12. After popping out these two, only 9 would be there in the stack, and after applying the operators between these two, we are getting the result to 12. So push back the result to 12 onto the stack again. And next symbol is 8. Since it is an operand, we are supposed to push onto the stack. Already 9 and 12 are there. Now we are going to push 8 also onto the stack. The next symbol is operator. Since it is an operator, pop out the top two elements. The top element is 8 and the next top element is 12. We popped out these two. Inside the stack only 9 is there now, and the current operator is plus. Apply plus operator on these two values. Now you would get the result to 20. We are supposed to push back the result onto the stack again. Next, if you check, it is an operand. Since it is an operand, you push into the stack. Next symbol, if you check, it is the operator. Since it is the operator, we are supposed to pop out the top two values. The top element, the first top element is 4, the second top element is 20. Pop out these two. After popping out these two, only 9 would be there in the stack. Apply the current operator, which is the division operator. If you apply the division operator between these two, we would get the result of 5. Push back the result onto the stack again. Now check for the next operator. which is minus operator. Since it is an operator, pop out the top two element. The top element is 5, the second top element is 9. We popped out these two. Now the stack would be empty, and apply the current operator, which is minus operator, and you would get the result 4. Push back the result onto the stack. Now the stack was empty. Now you push this operand, the result 4 into the stack. Now there is 4 in the stack, and check for the other symbols if there are any other symbols left out in the given expression. No, all the symbols we have scanned here in the given input expression, and this is going to be the final answer. So for the given input expression, we just converted that into the postfix expression, and we performed the evaluation, and at the end of the evaluation we got 4 as the final answer. So for the actual input expression, the answer is going to be 4. This is how, using the stack data structure, the actual input expression can be evaluated. First we are supposed to convert it into postfix and then perform the evaluation of the postfix. We would get the final answer. Thank you.